Let's take a look at some practice problems, and we're going to start by looking at number 10 from the CEMC practice work or courseware work. And we're looking at the parametric and vector equations of lines in R2 section first, starting with number 10. The question tells us that a vector with the equation r is -2, -9, plus t 1, 8 intersects with the parabola y equals 2x squared minus 3x plus 1 at the points A and B. Determine the length of AB. So we're going to have something like this. This is approximately correct, not exactly correct. We're going to have our parabola, and we're going to have some line. We're going to find the points A and B, and then determine the length of AB. And maybe I should adjust the screen so you can actually see what I'm writing. That's better. The first thing I'm going to go ahead and do here is rewrite my vector equation in parametric form. So I'm going to have x equals -2 plus t, and y equals -9 plus 8t. And I'm looking for these 2 points of intersection here, A and B. And what do I know about those points? Well, they are points of intersection. They are going to exist on both of my curves, so my linear line and my parabola. And so at those values, they're going to have the same x and y values. And there's going to be 2 of them because it's a parabola, so it's going to intersect at 2 different points. So let's go ahead and find those values. We are going to do that by using substitution and substituting in our equation for our x value into our quadratic equation, and the equation for our y value into our quadratic equation. And then we can go ahead and solve for our variables as needed. So let's go ahead and sub in these values and see where that takes us. So instead of y, I'm going to write -9 plus 8t equals 2 times x squared, x is -2, plus t squared minus 3 times -2 plus t plus 1. And notice we're only working with one variable now. The only thing I need to go ahead and solve for is my t value. And my different values of t will tell me the location of my different points of intersection. So let's go ahead and work through that. So -9 plus 8t equals 2 times 4 minus 4t plus t squared minus, well, let's change this to plus -3 times -2 is 6 minus 3t plus 1. Let's keep going and tidy this up a little more. -9 plus 8t equals 8 minus 8t plus 2t squared plus 6 minus 3t plus 1. Everything's basically on the same level now, so we can start to collect some like terms. And I'm gonna bring everything over. So 0 equals 9 minus 8t plus 8 minus 8t plus 2t squared plus 6 minus 3t plus 1. Let's find some like terms and start collecting. I'm going to start with my squareds. There's only one, so that's it's pretty easy to handle. 2t squared. Next, let's take a look at our t's. -8t minus 8t minus 3t. So -8 and -8 is -16. Minus another 3 is -19. So minus 19t. And then our constant. So 9 plus 8 is 17. Plus 6 is 23. Plus 1 is 24. And now it's just a matter of solving this quadratic equation. There's multiple ways we can do this. We can factor, we can use the quadratic formula, we can graph and find the points of intersection. I'm just going to write the factors. I'm not going to go through calculating them at this time. That is a tool or skill that you should have in your toolbox already, so I'm pretty confident that you will know how to do that. You can use methods like looping as well. And t is going to be equal to 3 over 2 and 8. So the points on the line that intersect the parabola occur when t has these values. So we're just going to sub these points back into our parametric equations to find them. So my points are going to be, so point A is going to be at x is equal to -2 plus, we're going to use our t value of 3 over 2. So -2 plus 1.5 is -0.5. And my y value is going to be -9 plus 8 times t, which is 3 over 2. So -9 plus 8 times 3 over 2 gives us 3. So A is at the point -0.5, comma 3. Then let's find our B value. So point B is at, same equation again, x equals -2 plus t. T is 8, so we're going to be at 6. And my y value, -9 plus 8 times 8. So 64 minus 9 is 55. And so point B is located at 6, 55. Now that we know those points, we can just use our magnitude of our vector formula. So magnitude of AB is equal to, let's take our x values, x2 minus x1, or a1 minus b1. So we're going to have 6 minus -0.5 squared plus 55 minus 3 squared, which is going to give us 13 over 2 squared plus 52 squared, which in exact form is going to give us root 10,985 over 2. Our next question comes from the worksheet for intersection of lines in 3 space, and we're looking at 8C. So for number 8, we're given the equation for 2 lines. L1 is 3, 0, -2 plus t, 3, 1, -3. And L2 is 15, 4a plus s, 5b, -5. And we need to find the values for our variables that will allow us to have, and we're looking at C, we want these lines to intersect. Let's see how we're going to go ahead and do that. To ensure that the lines intersect, there must be a solution to the system of equation where we set the components of these lines equal to each other. So we're going to start by putting these both in parametric form and then setting the pieces equal to each other. So L1, x equals 3 plus 3t, y equals 0 plus 1t, so t, and z equals -2 minus 3t. And then our line L2, x is going to equal 15 plus 5s. Y is equal to 4 plus b times my parameter s. And z equals a minus 5s. Since I'm looking for a point of intersection, I'm looking for the point where these are all equal to each other. So a point of intersection exists on both lines. So the x, y, and z components are all the same. So those portions of the equations are going to be equal to each other. So I can have my equation 1, where 3 plus 3t equals 15 plus 5s. And we can tidy that up a bit. So we can say that 3t equals 12 plus 5s. And equation 2, t equals 4 plus b s. That's fine. And equation 3, negative 2 minus 3t equals a minus 5s. And we can say that negative 3t equals a plus 2 minus 5s. And I notice that I have a 3t up here, and I almost have a 3t here. And so I'm going to adjust this a little just to make it look even more similar. I'm going to divide each side here by negative 1. So I'm going to have 3t equals negative a minus 2 plus 5s. And now I can go ahead and use elimination to solve for some of these variables. So I'm going to take a look at equation 1 and 3, and I'm going to subtract them from each other. So equation 1, 3t equals 12 plus 5s. Equation 3, 3t equals negative a minus 2 plus 5s. The brackets aren't strictly necessary, but they help us start to see a pattern here. And as I go through, 3t minus 3t is 0. 5s minus 5s is 0. So I'm going to have 0 is equal to 12 minus a minus 2. And that looks pretty good. I can rearrange and solve for a now. So 12 minus 2 is 10. 0 equals 10 minus a. A is equal to 10. Actually, conceptually, I did the right thing. I made a practical mistake, though. Let's try this again. So remember, we're subtracting these. So it's 12 minus negative a minus 2. So it's going to be 0 equals 12 plus a plus 2. So 0 equals 14 plus a. So a equals negative 14. All right, now that I know my a value, I want to find my b value. And I can find that by substituting this value into one of my equations. Actually, I guess we can't do that this time, but we can use elimination again to solve for b. So I'm going to take a look at equations 1 and 2. So equation 1, I have 3t equals 12 plus 5s. Equation 2, t equals 4 plus bs. I'm going to multiply equation 2 by 3. So I have a variable that can be eliminated. So let's try that again. So 3 times equation 2 is going to be 3t equals 12 plus 3 times bs. So I can just do 3b times s. All right, that looks workable. Let's work through this. And we are going to subtract. 3t minus 3t is 0. 12 minus 12 is 0. And 5 minus 3bs plus 5 minus 3b times s. All right, so I have 0 equals 5 minus 3b times s. And this will be true if s does not equal 0. All right, we're going to rearrange this and solve for s. That's what we need to do here. So if I rearrange and solve for s, I'm going to find that s is equal to 0 divided by 5 minus 3b. And this is fine, but notice that we can't divide by 0. So my bottom value cannot be 0. So s cannot equal, what happens when 5 minus 3b equals 0. If we rearrange, actually it's not a restriction on our s value, it's a restriction on our b value. So this is what s equals, but our bottom cannot equal 0. So how do we deal with that? Well, 5 minus 3b is not equal to 0. So 5 is not equal to 3b. So 5 over 3 is not equal to b. So basically b can be any value except for 5 over 3. So I know my b value, I know my a value, and I can just plug those back into, one moment. Ultimately, what did the question ask us to do? It said, find the values of a and b that make the lines intersecting. So we've actually done that. So therefore, L1 and L2 will intersect when a equals -14 and b does not equal 5 over 3. Any other value is allowable though, so b is an element of the real. So b can be all real values except for 5 over 3.